So I believe the first one, and I think there's one of the participants also, audience in the audience also has brought this up. Are there any sort of limitations to this from a design or a sizing perspective? I see you've gone for a specific size of hose. I'm guessing that's probably to replace what's already existing. But are there any limitations there?
No, there is absolutely no limitations. We can go to hose in a diameter as small as like 0.4 millimeter or 5 millimeter. You can extrude the parts as thin as 0.5 millimeters. So there is no limitations. And in fact, this is the advantage of Santoprene TPV, because you can go as you can make parts as thinner as possible, which is not possible with an EPDM compound. For with EPDM, you need to meet or meet a minimum thickness, for example 2 millimeter or so, to meet the requirements, whereas Santoprene can go down as low as 0.5 millimeter.
Fantastic. Okay. And sort of a follow up to that is as far as the manufacturing process itself is concerned, right? I mean, it's sort of pretty similar between the two, but from achieving from an accuracy standpoint, right, or deviation or tolerances, how well does that stack up?
Yeah, the Santoprene TPV is known for the tight tolerance that it meets, especially in extruded compounds or injection molded compounds. You don't see a very large amount of shrinkage or swell in Santoprene TPV, unlike the EPDM rubber, which swells and shrinks much bigger than Santoprene TPV. So tight tolerance is easily possible with Santoprene TPV. So this helps to save a lot of cost to the OEMs, because they can make parts which are tighter in tolerance. They don't have to give an additional cushion or additional material in their processes, which will further increase their cost structure. So tight tolerance, yes, which is always possible with Santoprene.
Okay.